Yes, today's topic would be chemical bonding, right? And what we are supposed to do in this chapter, I would like to write the aim. What is the spectrum of subtopics which we would like to cover in this chapter? One by one, I would like to write it. But remember, if you wanted to know the complete meaning and the spectrum of things what we will be dealing in this chapter, first thing you must understand is what is a bond. Let me define that first. What is a bond? What is a bond? Now everyone have their own perception of what exactly is a bond and the English meaning of bond. But remember, what is a bond is, the bond is a force. You cannot tell stories that you give me one, I give me one, we both put it at this center, and then we both achieve the octet and live happily. This is one of the perceptions what we have. Mind you that. So it's not like that, someone told me that, you don't have an octet. You don't have 8 electrons in your outermost shell. So what you're supposed to do is you give me one, I give me one, we both share, and then we put it at the center, and then the bond is established. Right? Superficially, yes, the perception might be correct, but technically what exactly is a bond? So if you can know what exactly is a bond, then I think we'll get into the spectra of subtopics what we will be dealing in the chemical bonding. Right? So what is a bond basically? Bond is basically a force. I would like to give a pause here. Bond is nothing but a force. It is a force. So if someone is asking you whatever, it might be a metallic bond or covalent bond or some other bond or whatever, but I think if he's asking what is a bond, then I think you should be underlining the word force. It is basically a force, whether it is ionic bond or covalent bond or metallic bond or whatever bond, it's nothing but a force. So understand that a bond is not a story. You give me one, I give me one, we both put it at the center, we both have achieved octet, and then we are living happily. No, absolutely not. You might be having that perception, but technically speaking, bond is basically, I would like to write, bond is a force. I would like to underline, it is a force. It is a force. And what is that force doing? The force that binds two atoms or ions. It can be atoms or it can be what? Ions. But basically it is nothing but what? Force. So bond is basically a force that binds two atoms or two ions. And where is that situation happening? In a molecule. In a molecule. You must understand this. So bond is basically a force. So if someone is asking you what's a bond, then don't tell all the big perceptions what you have, but rather it's so simple that bond is basically a force that binds two atoms or ions in a molecule. That's what is called a bond. Now if you insist on bond to be a force, then I think you have no one force in chemistry. You have absolutely no one force in chemistry. You have several forces in chemistry. Right? When I say several forces in chemistry, then you have several bonds in chemistry. So forces can be, so since bond is a force, this can be an electrostatic force. This can be an electrostatic force. So since you said bond is a force, then forces can be many ways. You have many forces in chemistry. One is basically the electrostatic force. The other is a covalent force. The other is a metallic force. You must understand, you have several forces. You have several forces. So when you say a bond is a force, then understand that force can be what? Electrostatic, covalent, or even metallic force or some other forces, right? So these forces are actually binding two atoms or ions in a molecule. That can be called as what? A bond. Now what happens, suppose if the two atoms or ions are bound by electrostatic force, we call that bond to be an ionic bond. So electrostatic force is only existing between oppositely charged ions. So that's why I have written a bond is a force that binds two atoms or ions, both. So if you have oppositely charged ions, and the force that naturally exists is of course what? Electrostatic force. And remember that when you have electrostatic force between oppositely charged ions, we call that to be an ionic bond, you must understand. Then you have covalent force, and then we call this to be a covalent bond, you must understand. And then you have a metallic force, which is also a bond, and I call this to be a metallic bond, you must understand this. So see the way we have pulled out some inferences. You must understand that a bond is basically a force that binds two atoms or ions in a molecule, and in chemistry we have no exclusively one force. You have several forces. If electrostatic force is binding them, then we call that to be an ionic bond. If covalent force is binding them, we call that to be a covalent bond. And if you have a metallic force, then we call that to be a metallic bond. And you have several other types of forces also, hence you have several bonds. You must understand that, right? So understand that this is how the definition of the bond is. Now what I will do, I will take you through all the subtopics. Which we will be dealing in this chapter, chemical bonding, such that we have a prerequisite idea of what exactly we are doing in this chapter, right? Then if this is the case, then observe what we will be dealing with is like this. We will be dealing with all this. We will be getting into details of one electrovalent bond. Electrovalent bond, you must understand, that's nothing but the other way of calling an ionic bond. It's an electrovalent bond. You must understand that. The second one is properties of ionic bond. The properties of ionic bond. And then, since most of the ionic compounds are solids, and solids have a definite shape, so we cannot ignore in giving the details of the shapes, because they form lattices, crystal lattices. So we will define what exactly is a lattice, and we will say some energy emissions or absorptions. So I call this to be lattice energies, and the equations related to what? The lattice energies, you must understand. So what are we doing in this chapter? First, we will get into what's an electrovalent bond is. We'll illustrate it. Second, we'll get into the properties of ionic compounds in complete detail, because you have questions in this. The third one is basically lattice, and why the lattice is coming into the picture. Because ionic compounds are solids. They are basically solids. And when they are solids, they have a definite shape. They form crystal lattices. So what are the types of lattices we will see? And when the lattice is formed, there will be energy changes. We will actually propose an equation for the lattice energy, and we will get into how to determining what? Lattice energy, that is the Born-Haber cycle. The Born-Haber cycle for finding lattice energy. This is the other one what we are doing, Born-Haber cycle for determining what? The lattice energy. And then you have the fifth one. Then we get into the types of lattices. That is, we will see what exactly is a HCP, hexagonal close packing. What is that? We will see BCC, that is body-centered cube. And then you have your FCC. And these are nothing but unit cells. Now, unit cell is the simplest sample of a lattice. So when you're speaking of lattices, we are basically speaking of what? Unit cells. So these two are synonymous. Lattice and unit cell both mean the same. So what we are doing, First we'll discuss electrovalent bond, then we get into their properties, then we define what is a lattice, then we go for lattice energy equations, then we'll determine the lattice energy through Born-Haber's, theoretically through Born-Haber's cycle. Then you have types of unit cells, that's nothing but the types of lattices. You must understand. And then we get into the covalent bond. The covalent bond, then we propose the concept of overlapping. The concept of overlapping, that is basically I'm referring to the valence bond theory. It's nothing but the valence bond theory, and whenever you propose a theory, it will be having, I don't know whether people will have merits or not, but definitely people will be having demerits. Right? So the demerit is actually being corrected, and then you propose another theory and the textbook becomes fact. Right? So you must understand. It's a covalent bond, concept of overlapping, that's valence bond theory. Then you have your concept of hybridization. The concept of hybridization. Then you have the dipole moment. Then we get into dipole moment and its applications. And then we will say the valence shell electron pair repulsion theory, PRT, and its applications. And then we get into the concept of polarization. The concept of what? Polarization. And then we get into the molecular orbital theory, MOT. The molecular orbital theory, and then you have hydrogen bonding and its applications. You must understand. You should be having a pre-idea of what exactly you're doing in chemical bonding. You must understand that. Initially, I was telling you what's a bond. Bond, you might be having a perception that yes, two people participate in bonding. Our teachers told in school, the two people participate in bonding, of course, to achieve stability. Two atoms are unstable, so they will combine for the reason to achieve what? Stability. But remember, yes, that's fine. That's in terms of energy. Stability is a function of energy. Yes, atoms do combine to form molecules. But if someone is asking you what's a bond, I prefer to insist on the word force. It's a force that binds to atoms or molecules, atoms or ions in a molecule. And since force is no one thing in chemistry, you have several forces, hence you have several bonds. And this entire chemical bonding chapter I'm running through electrovalent bond and then its properties and also even the dative bond. Or otherwise I call this to be coordinate covalent bond. You must understand. You have this dative bond or the coordinate covalent bond. These are the things which will be going through in complete detail, where you will be getting the total information regarding each and everything here. And people who are writing their exams must listen to me carefully. So what I'll do, each subtopic I'll put it to be a Roman number. So I start with Roman number, that's nothing but electrovalent bond. Let us see what exactly is this. Observe carefully here. Here, let's get into Roman number 1. That's ionic bond. Or I call this to be electrovalent bond. Let us have complete details of this. You know, the most convincing, I draw the attention of everyone because I slip on to the topic now, right? Remember, the most convincing of all the bond types is ionic bond, right? Why? Why it's most convincing? Because covalent bond is something where the definition itself, many questions remain unanswered as far as the covalent bond definition is concerned. But ionic bond definition, it's most convincing because, watch here, if you see, right, if I can write what exactly is an ionic bond, the most convincing bonds is, of course, what ionic bond, at least for our understanding. Convincing in the sense for our understanding, right? Now, what is basically ionic bond? Now, look at this. Electrostatic force. So, basically, ionic bond is nothing but electrostatic force. Bond is a force. So, now ionic bond is an electrostatic force. I would like to underline. This electrostatic force that binds oppositely charged ions. You must understand, electrostatic force that binds to oppositely charged ions is called ionic bond. Now, why it is most convincing? I'm very happy with the definition because I think it's convincing and nothing is left to actually explain in this. For example, if this is a positively charged ion and this is a negatively charged ion, and in between you have this electrostatic force and the bond is formed. And the bond is formed. What else you wanted to explain? You don't need to, because the force that binds is electrostatic force which naturally exists because of oppositely charged ions. That's not the case with covalent bond. Look into this. In the case of covalent bond, right? Now what is so convincing here? What is so convincing here in ionic bond is, if you ask me, where does the strength come from in ionic bond? If that's the question, where does the strength come from in ionic bond? Then I think it is nothing but the positively charged ions and the negatively charged ions, and you always have an electrostatic force between them, and that's binding is highly convincing. The strength of an ionic bond is derived from the electrostatic force which naturally exists between oppositely charged ions. That's the case. But such thing you cannot say that in case of covalent bond. Look into this. What you do in covalent bond, you give an electron, I give an electron, and this is a shared pair. That's a share pair. Now what is happening here through sharing is both A comma B achieved octet. Hence I can say this AB is stable because each of you have achieved what? Octet. But in this process of defining covalent bond, I can't understand one thing. I cannot understand one thing. What you're telling basically is, since A is deprived of the octet, B is deprived of the octet, so A was calling B, let's share a bond pair, and then we both will achieve octet. We are sharing. I understood that. I understood it completely. I have no issues with that. But what is not is this. The story is fine, but where does the strength come from? Where does the strength in covalent bond coming from? Where does the strength in the covalent bond coming from is something which is unanswered prima facie. In defining the covalent bond, you must understand that. Right? So, the most convincing is ionic bond, And if you ask me where does the strength come from in ionic bond, then I'm ready to say that yes, you have oppositely charged ions, so you have an electrostatic force prevailing naturally, so that is binding these two ions and the strength is derived in that fashion. But the same way, you cannot tell where the strength is derived from and what is holding these two atoms A and B, these two atoms A and B. What is that which is holding them is not convincingly explained. It is not convincingly explained as we do it in ionic compounds. Where does the strength come from? The only thing what you're telling me is basically A is not getting its octet, B is not getting its octet, so both are deprived of octets. So both said let's share a bond pair and then form what? A covalent bond. Fine. But where does the strength come from is not answered here. So most convincing of both the types is of course what? Electrostatic force, and the details of where the strength comes from in covalent bond will be taken up when the covalent bond we will discuss. So on relative basis, why I'm discussing side by side is basically telling you that ionic bond formation, the strength is coming from the oppositely charged ions and the electrostatic force that prevails naturally. Right? Let's get into details of the ionic compounds now. Watch carefully here. Now what are the prerequisites for ionic bond? What are the prerequisites for formation of the ionic bond? Prerequisites in the sense, what are the conditions? These conditions can be sufficient or necessary, or both. So the necessary and sufficient conditions, conducive conditions for the formation of ionic bond, let us go and discuss. The first thing what I'm telling is, 1, a bond between a metal and a non-metal is essentially ionic. You must understand. A bond between a metal and a non-metal is essentially ionic. So, if someone is asking you, giving you a set of ionic compounds and asking you to pick up which are ionic, then it's for you to pick up a metal and a non-metal. Is essentially ionic. They are ionic. So, if you are well versed with the periodic table, then metals are placed to the extreme left of the periodic table, and non-metals are placed to the extreme right of the periodic table. So the bond between extreme left fellows and the extreme right fellows is essentially ionic. It's ionic. Now the question is, people might ask me, you're telling ionic, but if you say that extreme left and extreme right are ionic, then people will ask me, in the D block you have metals, and what about these metals with the non-metals? Whether you are a D block or F block or a first group or second group, doesn't matter. When you are a metal and a non-metal, the bond between them is essentially ionic. But yes, is it 100% ionic? Is it 80% ionic? It is 50% ionic? Yes, it is a point for discussion. It's a point for discussion. It is a point for discussion. Because people might ask me, the most fundamental thing, if you say a bond between a metal and a non-metal is essentially ionic, then people might question me in this fashion. I question this on your behalf. Watch. This is NaCl. This is AgCl. And remember, Sodium is a metal, chlorine is a non-metal. Silver is a metal, chlorine is a non-metal. But the issue is, this belongs to first group. When you belong to first group, you are basically extreme left. But this fellow, silver, is a D block. You're basically at the center of the periodic table. And remember, whether you're at the center or extreme right doesn't matter. But these two are what? Essentially ionic. Essentially ionic. But if someone is asking me to pick up that compound which is more ionic, then it would be extreme left versus extreme right, or otherwise extreme left bottom to the extreme right top. If that is the case, then this seems to be 100% ionic. This seems to be not what? 100% ionic, but remember, both are ionic compounds. Both are ionic compounds, you must understand. Both are ionic compounds. If I can fix a property to you for better understanding, then if you drop NaCl in water, it dissolves. And if you drop AgCl, which is also ionic, in water, in fact it doesn't dissolve, in fact it is a precipitate. It's basically a precipitate. You must understand. Our teachers told us in school that ionic compounds are soluble in water. An ionic bond is a bond between a metal and a non-metal. Here is a metal and a non-metal, metal and a non-metal, both are ionic, but the properties differ. One is soluble in water, the other is what? A precipitate. Forget about solubility. So there are some essential conditions and sufficient conditions. Right? And I would like to tell you, but whatever might be the properties they exhibit, right? I think they are what? Ionic compounds, you must understand that. So what I'm telling is the first condition, the prerequisite for any ionic bond formation is basically a bond between a metal and a non-metal is ionic. But immediately we encounter some issues. What are the issues? You can see here both are ionic, right? This is more ionic, that's less ionic, but both are ionic, right? And remember, you have NaCl in water getting dissolved in water, and then silver in water is a precipitate. How do you answer that? How do we answer this? Let us get into the details. Yes, how to answer this? Well, I introduced to you the concept of polarization. The concept of what? Polarization. Now, what is this concept of polarization about? Let us understand. Before I introduce the concept of polarization, why are we proposing it? Why are we proposing it? So let me write the aim. Let me write the aim. Why do we propose this? The aim is to judge covalent character. I would like to underline covalent character where in ionic compounds. So basically we are judging covalent character in ionic compounds. So we are sticking to ionic compounds itself. But since we said not every ionic compound is 100% ionic, that means that some percentage of covalent character has been crept into these ionic compounds. Now, why did it creep into it? That can be explained through the concept of what? Polarization, and you will get questions in this, in all the pre-engineering tests and pre-medical tests which you will be writing. That application I will tell, but let me introduce what exactly is the concept of polarization. So if someone is asking you, what is polarization? Why are you introducing this to us? Then tell them that I'm judging covalent character in basically ionic compounds. In ionic compounds, so we are sticking to what? Ionic compounds and trying to judge what? The covalent character. So in this case of NaCl, AgCl, this has some covalent character, and this is 100% what? Ionic. Both are ionic compounds. But I think the AgCl is having some percentage of what? Ionic character, covalent character. Why and how is a question which can be answered through the concept of what? Polarization. And I define what is the concept of polarization. So remember first, why are we introducing the concept of polarization? Is simple. We wanted to judge the covalent character in ionic compounds. So what is polarization? What is polarization? Let me introduce this. What is polarization? Let me define it. If I define, then the distortion I would like to underline. So polarization is basically distortion. Becoming shy. And you will become shy because of the environment you are facing. Well, I am rigid right now, like this. I'm rigid. Well, I'm shy, then I look shy. This is not shyfulness. So when you're shy, you're basically doing something like this. You're shy. So to understand polarization, it's distortion. Distortion. Now, who is getting distorted? If I continue, the distortion of negative charge cloud. Now, what is this bloody negative charge cloud? Is basically, I'm referring to an anion, say B minus. An anion. So distortion, shyness of what? Electron negatively charged cloud. Well, the thinking in which you must develop this thinking that whether it's an electron or a negative charged cloud, negative charged species is always viewed as a cloud. And a cloud has a diffusing property. So what we are doing, we see, I would like to define what is polarization, the distortion of a negative charge cloud. So you understand that whether it's an electron or an anion which bears a negative charge should be viewed as a cloud. And a cloud has a diffusing property. A cloud has a diffusing property. So I think the word distortion used by me seemed to be justified. After all, it's a cloud. It's a cloud, right? So what is polarization? Is the distortion of the negative charge cloud on approach of a cation, that is A plus. Now why there is distortion? Why there is shyness? Why there is distortion? Why there is shyness? That is because a cation is approaching you. When the cation approaches, the negative charge is basically distorting. The negative charge cloud is basically distorting. Well, I show this entire episode in the form of in a different picture. Watch carefully here. Here is a cation. Here is a cation. And here is an anion. This is a cloud. This is the negative charge cloud which I am referring to. That is a negative charge cloud which I am referring to. So what is happening? This is approaching it. So cation approaching an anion. When you approach, this negative charge cloud distorts. So the cloud completely different shape. It has gone into a different shape. Look into this. This and this are different. This is a distorted negative charge cloud because the A plus was too close to the B minus. So I call it to be shyness, distortion. The distortion of the negative charge cloud on approach of cations, this can be termed as what? Polarization. You must understand. That can be termed as what? Polarization. Now, using this concept, we would be in a position to explain why some ionic compounds will be possessing what? Covalent character. And hence the properties of even covalent compounds seen in what? Ionic compound. Well, if that is the case, let us explain again once. We are discussing the concept of polarization. Why are you discussing it? Because we wanted to judge the covalent character in ionic compounds. What is polarization? Polarization is basically distortion of negative charge cloud on approach of a cation. So when the positive ion is approaching this cloud, this is the original structure of the cloud. Because this A plus was far away. And when you are approaching and go close, you find the distortion. Well, I wanted to know two things. The first thing is, why should a cation approach an anion? Well, a cation which bears a partial positive charge is electron deficient. And naturally, you will move towards a negative charge cloud which is electron rich. So what you do is, since you're deprived of electrons, you go close to the anion and start sharing its electrons. Start sharing its charge. That is a better way of understanding. Start sharing its negative charge. You can say, earlier you formed a cation, you are an anion, So you lost electrons, you gained electrons, your anion is separate, your cation was separate, but when one is approaching the other, the negative charge getting distorted is giving signals that yes, come down. Yes, come down. Yes, Mr. Cation, come down and start sharing my charge. It is sharing the charge. So when you start sharing the charge, I think some amount of what covalent character has been induced into ionic compounds, you must understand. Let us explain properly. Watch. I comment on, I'm commenting few things. I comment on both the cation and the anion. I make some comments on both anion and a cation. I want to make comments on that. During this episode of what? This entire episode of polarization, shyness, cation approaching the anion, and the anion getting shied, distorted. In this entire episode, I wanted to comment on what? Cation as well as anion. Well, I wanted to comment first on cations. First of all, if this is small, if this is smaller, when you're smaller, you basically get too close to the anion. The cation, which is smaller, is getting very much close towards the anion. When you go close to the anion is getting too much distorted, too much shy. You're feeling distorted. So, if the comment which I make on a cation is, if you're small, then you get too close to what? Anion. You get too close to the anion. When you get too close to the anion, then what happens is distortion more. And I was telling you this distortion itself is polarization. Polarization more. I'm commenting on both cation as well as what? Anion in the entire episode of this shyness. So when you're too small, you get too close, distortion more, polarizing more, and I would like to make a comment. Such cations are said to be more polarizing. Such cations are said to be what? More polarizing. So if a question is asked, which cations are more polarizing? The answer must be smaller ones. Smaller cations get too close to an anion and the anion feels shy. Feeling shy means you get more distorted, and such cations are said to be more polarizing. More polarizing. Must understand? Let me comment on an anion. If the anion is big, if it is big, then distorts more. Then polarization is more. Then such anions are said to be highly polarizable. Highly polarizable. These can be called as highly polarizing. Highly polarizing. And this is highly polarizable. Well, I'm making comments on both. I'm not leaving anyone. In the case of cations, I choose a smaller cation. Smaller cation goes close towards anion. That results in more shyness in the anion. You must understand. And such cations are called highly polarizing. And what happens now, these comments are further taken forward by Mr. Fajan, and he framed rules. These comments have been now converted into rules. So if we can put properly, then it is like this. Watch carefully. Fajans rules. And this comments on both anion as well as what? Cation. And what is the rule? 1, smaller the cation, high is polarizing power. High is what? Polarizing power. And when high is polarizing power, Fajans says such compounds you will find covalent character more. You must understand. Such compounds you have covalent character what? More. And when coming to this, bigger the anion, high is polarizability, then the covalent character is more. Simply speaking, right? I would like to write, as a rule in chemistry. Which rule? Fajans rule. As a rule in chemistry, highly polarizing cations combine with highly polarizable anions. You must understand. Well, I have some applications for you. Shall we go in for applications? Let's take it. Right. Now what we will do, we'll take an example. An application. And these applications are questions in exam. Mind you that a straight application which I was about to write. Watch carefully before I rub this. These Fajans rules are not, it's nothing but comments. Comments made on cation and anion. Smaller the cation, bigger the anion, polarizing powers are more, and the covalent characters are more. So if that is case, as a rule in chemistry, highly polarizing cations combine with highly polarizing anions. Let me take an example. Watch. Applications of Fajans rules. Applications of Fajans rules. What is the first application? Look into this. The main ore of lead is galena, that is PBS, and not PBO. That is the first one, assertion reasoning question, a theoretical question. The main ore of lead is galena and not PBO. Similarly, the main ore of silver is Ag2S and not Ag2O. If you ask someone this question, then you might turn philosophical. It's God's creation. What I will do, it's ridiculous. What I'm basically telling is, if you dig the surface of the earth, then I think more is what? Galena, and you hardly find PBO. You dig the entire surface of the earth, then I think you get more Ag2S and not Ag2O. And we have to answer why. Why? If that is the case, Then recollect. Please recollect. What was the rule? The rule in chemistry is highly polarizing cations prefer to combine with highly polarizable anions. That was the rule. So I asked lead Pb plus 2, go and combine with sulfide, go and combine with oxide. I gave two options to lead. Go. Please go. You can combine with this or you can combine with that. But remember, I think the size of S minus 2, which is an anion, is bigger than the oxide. The size of sulfide is bigger than oxide. And if you look into the comments made by Fajan, bigger the anion, more is shyness, more is distortion, more is polarizing power, more is covalent character. So even though it has two options, when the Pb plus 2 is approaching this sulfide cloud, when it approaches, then this gets distorted. That is getting distorted more. So this bond, it implies the PBS seem to be more conducive for bond. Because when the lead is approaching, the sulfide is what? Distorting. It's telling, please come down, we'll share the electrons. On the other hand, if you look into this bond, this is conducive. If you look at this bond, the lead is approaching, but the oxide is not shying, it's just standing like this. No shyness, no distortion, it's just standing. Then the bond formation is non-conducive. You must understand. So all in all, what I mean in this is basically this. Pb plus 2 plus S minus 2. This bond conducive for the formation of PBS. Whereas Pb plus 2, O minus 2, giving rise to PbO, is basically non-conducive. Not favorable, conducive in the sense, not favorable. And the reason for that, if you look into the reason for that, reason, the size of S minus 2 is very much greater than O minus 2. So this lead plus 2 can approach this and get close. When you get close, more polarization, more is covalent character. You must understand. This question has been asked in the exam. Which of the following justifies that the main ore of lead is galena, not litharge? This is litharge. And the main ore of silver is silver glance. This is silver glance. This is galena. And this is litharge. This is silver sulfide. This is silver glance. And this is silver oxide. And out of these, this is abundant. And this is abundant. You must understand that. And that can be explained through what? The concept of polarization, you must understand.